Okay, today we're starting the circulating cooling water system in a power plant. The plant's coming online. We have the equipment operators out checking the equipment, doing the walkdowns, making sure all the breakers on these pumps are racked in. Control power ready to go. Make sure the breakers racked in for the discharge valves and our lube water pumps. The big thing is make sure all the drains are closed and the manway hatches are in on your surface condensers. Starting up a pump like this with manways open, I can flood the building fairly quickly. These are 2,000 horsepower motors. They run 7,200 volts. They're capable of pumping 93,000 gallons a minute. This is a once-through cooling water system. We're pumping out of a reservoir. Some plants pump out of the river, a lake, different water sources, and the water's returned back to that water body. So you get a little bit of thermal pollution from this style of plant. Nowadays, everybody's using cooling towers. So instead of going back to the reservoir, it'd go to a cooling tower and then repump back in. This level here is the reservoir level. These are traveling screens. They're a screen with about a 1/4 inch opening that removes the larger debris that keeps from plugging the surface condenser tubes. We have our Circ Water pump. Say it's a 2,000 horsepower propeller type pump. The discharge valve opens. It's closed when the pump starts and then opens 20% in 10 seconds. Then in 10 minutes it'll be full open. When the pump shuts down, this closes and then the pump shuts down. There is no check valves in this system. This is somewhat common in a lot of large circulating water systems. Sometimes they'll have check valves. There's a lot of water moving, slam against check valves. So they use a butterfly valve with a motor operated valve on it, limit torque. Usually we'll run 2 pumps full load. There's one line that comes up, then it splits off. There's 2 condensers, as there's 2 low pressure turbines. The water counterflows through the condensers. This stream here will go through condenser A, the inner pass, then go through condenser B, then out to the seal well. Whereas this other side comes in through condenser B and through A and then down. It's called a seal structure, seal weir. There's several different names. This is a critical part of this system, fairly simple. We'll go over more of this on the whiteboard. Up here we have vacuum pumps. These are liquid ring vacuum pumps. They pull a slight vacuum on this tank, which pulls water and air off the water boxes of the condenser. There's actually lines here and here. It's not drawn quite right on this. But they keep the condenser from getting airlock from the circulating water. It will drop air out. There's air entrained in the water, and then as it heats up and you get a pressure drop, you can start building up air, which will airlock these 2 upper tubes, and you'll start losing vacuum. Vacuum on this system is critical. If vacuum starts rising during the hot part of the summer, you're going to start losing plant efficiency. You're going to lose some megawatts. You can lose a lot of money if your vacuum starts coming up, like you have a drain valve open and you're sucking air in. That can cost you a couple megawatts. And if the price of power is $200 to $1,000 a megawatt, you're going to lose a lot of money from just some valve being open. The water in this tank can be under a slight vacuum, but the height of the water column here, it'll actually be a positive pressure down here. Every 2.31 feet of water is 1 psi. So if you're down here 2.31, you just gained a psi. If you're down 10 feet, you're 23 feet, you just gained 10 pounds of pressure on it. Okay, our plant operator has just said that the equipment looks good, it's ready for a start. We're going to start the lube water pump first. We're starting all the A pumps, alpha. I'd use the phonetic alphabet when you're calling out pump numbers over the radio. We've had guys supposed to go to B pulverizer, and next thing you know, E pulverizer is doing something weird because they got the wrong one. So it's better just to use the phonetic alphabet when you're calling stuff out on the radio. These pumps are a small pump. The whole purpose of these is just to provide filtered water through your Circ Water pumps. These have a rubber bushing in the pump part of it, and it requires this water for cooling the bushings. Also flushes out dirt and debris. Without these pumps running, your Circ Water pump will run about 30 seconds and trip. There is a low trip on these. So it's a very critical piece of equipment, yet it's just like a little irrigation pump. They're insignificant, but perform a huge function. Okay, we're starting the pump. Our alarms have cleared. We have water flow. Now we're going to start the main Circ Water pump. Before they do this, we're going to enunciate this in the plant so all plant personnel are aware that we're starting a large piece of equipment. We want people to verify there's no leaks on the manways, the drains on the surface condensers, expansion joint ruptures, and you want to keep people back from the seal structure. It will throw a lot of water out as that air comes through. So we're going to go ahead and enunciate the pump start. Attention all plant personnel, starting A alpha Circ Water pump, starting A alpha Circ Water pump. Please stay clear. You never know who's out there working on things, and so it's a good idea to enunciate it. Okay, we have our graph up here, or trend. This is critical. Always run trends. We have our motor current, thrust bearing temperature, upper thrust bearing, and motor stator temperature. This pump, like I say, is 7200 volts. It's going to pull a lot of current for starting. You want to keep an idea in your back of your head how many amps you can pull for how long on these large motors. And there's start time limits, how many starts per hour you can start them. Okay, we'll go ahead and start. We're pulling 200 amps, but that's as high as the instrumentation goes. It's probably pulling quite a bit more. See the discharge valve's closed. It's up to speed. You see the amps dropped off. Now the valve's starting to open, so now it's starting to pull some current as it pumps. It's nice the controller shows the amps too on it. So this gives you an idea that the discharge valve is opening. You want it 20% open, and then it'll take 10 minutes to go full open as it gives this line a chance to fill with water and the pump windings to cool down. There's a tremendous amount of heat developing these windings when you start them. The inrush current's very high. We're going to go ahead and start a vacuum pump. Like again, we're going to start all the A pumps. And once a month, we'll swap the pumps, run all the Bs. That way maintenance can check vibrations and do oil samples. Pretty much everything on this screen is in the British units. Nowadays, everything's gone metric. So the young people, you really need to learn metric. This is the old school stuff, degrees and 1,000 gallons a minute. But metric will be the way of the future. The main point here, this Circ Water lube pump, this is not in auto. If this pump fails, this pump's going to trip in 30 seconds. And if you're at full load and both these pumps trip, your turbine's going to trip, and you're probably going to blow the rupture discs on your low pressure turbine because you just lost all the cooling water to your condensers. Plus you're coming offline. So that would be a major error. It could cost $1 million from somebody not making sure this thing is in auto. So if you're running your plants, make sure everything's in auto, beginning a shift. And pay attention to numbers. These numbers here are critical. If the screen starts plugging up, this will start dropping. You'll lose pit level. You'll get to a point where this cavitates. And it may get low enough to where the screen will no longer drive. The screen panels are driven into the frame and it won't run. So you have to shut the pump down and try and get the screen going again. So you're going to have to drop load. Same thing with the vacuum pump. It's going to auto. We're gonna have somebody walk the system down to verify there's no leaks, drains. This other pump we could start now, but it's gonna be about 10 hours before we're really gonna need it. But you don't wanna wait 10 hours to start this pump in case there's a mechanical problem. So probably about 8 hours out after we get the boiler running, start rolling the turbine. We'll go ahead and start this pump. You have to have cooling water to your condenser because we're going to have steam drains open. We're going to be dumping steam into the condenser as we warm up the main steam lines. So this is a critical piece of equipment for the boiler startup. Okay, that's it.